have to go see my youngest get an award this morning. So you guys get Mrs. Ballard. They do not. Okay. So let's go ahead and read that out loud together really quick. Okay, so on the count of 3, you ready? 1, 2, 3. Okay. When we see revolution on it, what does that mean I need to put in front of my integral? Pi, right? That's what we learned yesterday. So we're still putting pi in front, okay? The difference is, and if you look at those pictures, is we're going to have a big old hole in the middle, okay? It's going to be like, it would be like a roll of toilet paper or, paper towels, right? There's going to be a big hole in the middle of the volume. Now those we can calculate with a cylinder, but these are going to be things with a hole that wouldn't be cylinder-like, okay? We're almost at a donut. Calculating the volume of a donut is Calc 3. Okay, you need to be able to do it. A donut is actually called a torus. Okay, we won't be there in this class or next year's class. Okay, you got to do that one in college. All right, so the reason we call it the washer method is because it's one of these guys. Have you guys ever seen these guys before? So those are like, you put it between like when you're trying to like I don't know, I can think of it like being in a sink. Okay, you put that little thing in there, and it kind of it's a spacer in between.
It protects the metal
behind
the screw.
Yeah.
From
from scratching it. Yeah. So that's why they call it washer, is because of that. Okay, they're thinking about that kind of washer. How many circles do we see in that washer? There's one on the outside and one on the inside. So that's exactly what we're going to do. We're going to have an outer circle and find the volume of that, and we're going to find the inner circle and find the volume of that. Okay. All right. So I want you to just skim through those words really quick. Okay. You've got like 30 seconds to read those words. Okay. So you'll notice that they are taking into account that we have two circles, okay? So we have this one here, and notice the rectangle is touching the outer function. That is the outer circle, so we would have to do the radius of the outer circle, or the outer function, okay? And then we subtract the radius of the inner function. This one right here is inside, right? And it's going from this function down to the x-axis. So we have to take away all of that junk that's in there from the inside of the object, okay? We can do the same thing, right minus left, okay? But we're still going to have outer minus inner. Inside of here, though, we're going to be doing a top minus bottom thing, okay? Do you see how there's my axis of revolution, right? Do you see how this rectangle touches the blue one and the axis of revolution? And then this little one, the inside one, touches the red one and the axis of revolution. So we're still going to do top minus bottom inside the outer and inner. Or sorry, the outer and the, I wrote inside, the outer and the inner. Okay. All right. Before I do that, though, I want you to look at the difference between a disk and a washer. Okay. So yesterday, the function looked like this, right? Here was my axis of revolution. And that's what it looked like yesterday. Here's what today's looks like. Okay. All right. I'm going to say that it cuts off here. And here's my axis of revolution. Do you see how my region is touching the axis of revolution? That means it's a disk. My region is not touching the axis of revolution. That means it's a washer. Okay, so here I know I only do one circle. Okay, here I know I have to do 2 circles. Okay, all right. And this one here, the one in the second part of the notes, is the College Board's absolute favorite. I guarantee it's going to be on the AP test. Okay, I could 100% guarantee it's going to be there. That's how confident I am. Okay, I don't usually 100% guarantee. I usually like to leave myself an out. All right, let's read through example 1 together. So find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals the square root of x and y equals x squared about the x-axis. Sketch the graph, draw the representative rectangle. Okay, so I'm going to draw those two graphs, okay? I know my parent graphs, so I kind of know what they look like. If I didn't, I could plug numbers in, okay? I know that a square root graph looks like that, okay? So I know it's going to be at 0, 0, and I know it's going to have a value at 1, 1. Notice the graph is scaled weird, and it's going to curve this direction, okay? And then I know that my x squared graph, what shape is an x squared graph? Parabola, okay? It's an opening up parabola, and I know it too has it has its vertex at 1 at 0, 0, and then I usually go up 1 over 1 for the first value, so it's going to look like that. Okay? All right. Looking for the axis of revolution. It does say revolving, so we're doing a revolution. What axis are we revolving around? The x-axis. So I'm going to draw in my axis of revolution. I draw it in the sparkly rainbows. Okay? And I also usually try to shade my region a little bit. Okay. Do you see how this region is only touching in one point? That's the only amount we're allowed to touch in order for it to be a washer. Do you see how we have a huge gap in there? That is the indicator that we're using the washer method versus the disc method. Okay? All right, so which one of these, the blue one or the green one, is further away from the axis of revolution? The top one, the green one, right? So this here is our outer function, okay? Which makes, by default, the blue one the inner function. And by the way, we're only going to set up. We're not going to do the integration today, okay? So we're set up only. If you go look at the assignment I put out there yesterday, it includes this stuff. Just focus on getting all the setups done and practicing the setups, okay? The answer key is out there for you to practice that, okay? All right. So now I'm going to start setting up my integral. So for my volume. We're doing a volume of revolution. What do we start with? Pi every single time. Okay. What are my bounds? Look at what we marked. What's this one? 0. What's this one? Good. So 0 to 1. Okay. All right. I am now setting this up. So I have my outer. This one's going to be my outer. Actually, I'm going to use a different color. Use green. So this is going to be my outer function. Okay. And then I'm going to subtract my inner function, which is the blue one, right? And then we're throwing a dx at the end. Okay. Now it's like two little mini problems. Okay. I know I've got to deal with the green problem. I got to deal with the blue problem. So my green problem. I am now having to do top minus bottom. So inside here, I do top minus bottom. My top is the green. What was my green function? Square. We could say f of x, but I'm going to go square root of x because the other one wasn't named. That was kind of silly. So square root of x. What is the bottom? Nope. Look at it's a sparkly line, right? Look at where I drew my rectangle. I got to go, because remember, your area is always from the function to the x-axis, okay? So what's the value of the x-axis? So minus 0. And I want you to write the minus 0. We're trying to establish a habit, right? Because at some point, our axis of revolution might not be the 0. It might be 1, okay? It might be negative 1, okay? All right. Let's now look at the inner. We've got the outer done. So now I'm going to do the inner. And sometimes drawing that little line, that little mini rectangle, right? A line is a mini rectangle, helps us. Okay, so I'm now looking at the inner function. What is the top part of the inner function? X squared. Good. And then I'm going to subtract. What's the bottom? 0. Perfect. Okay. Just leave it like that for now. Okay. We're not going to integrate it you guys, we've done the integrations a bunch of times. I'm not worried about that part. I'm worried about making sure you set up. Okay? Are there any questions on how I did that? That is the basic one. Remember how yesterday we shifted an axis? College Board loves to shift an axis. They love a good shifted axis. So we're going to do shifted axis next, okay? So let's write down that last. This is the last success criteria you have to write this year. Isn't that great? 2 days before spring break, I got it in. The last one. All right, let's read it out loud together, okay, on the count of 3. You ready? 1, 2, 3.
I can calculate volumes of revolution using definite integrals and the washer method with the shifted axis of revolution.
Perfect. Okay. So the first one is not necessarily a shifted axis. It's they're putting it in a vertical manner, okay? And I believe every single one of these pictures is exactly the same. I use the same functions over and over. We're just going to do the volume in different ways, okay? So this first one, it says set up but do not solve. These are the most magical words on an AP test. Doesn't that sound great that we don't actually have to solve a problem when we get to earn points on an AP test? But it literally does say that. We'll pull out some free response problems tomorrow, and we'll actually see those magical words. They usually say write but do not integrate, okay? All right. An expression involving more than one or more integrals that would compute the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, x equals 1, about the line, oh, it does have a shifted one, about the line x equals -1. Shade the region being revolved and draw the axis of revolution and representative rectangles for R and capital R and lowercase r. Okay, so we've read it once. We're going to go through again and figure out what's going on here. All right, so first of all, which color is the function of the y equals x squared plus 1? Blue. So that's our blue one, right? Okay, and then y equals 0 is what color? It should be the red one, right? This is y equals 0, okay? X equals 0 is that's the green one in the middle, okay? That's the color I'm seeing. And then this one here is kind of some weird brown color, which I don't have a brown color. I'm going to use this purpley color, okay? Huh? What's wrong? No, it's at 0. Look at the axis is labeled right here. They didn't put the -1 on there. They only put the bounds. We have to draw that. Okay, we're revolving about this line, right? So I'm going to draw my -1 line in there. So this is my axis of revolution. Oh, it turned out sparkly yellow this time. Okay, so is my region that I've shaded touching my axis of revolution? Now, remember I asked that question yesterday like I was crazy, right? Because the answer yesterday was always yes. Today, the answer is probably no. That's how I know I have a washer, okay? All right. I know that I have to go across this way, so I know that I'm going to have my function in terms of y instead of x, okay? Oh my gosh, this one's really ugly. So I am going to start by getting this one solved for, whatchamacallit, x equals first. So how do I move the 1 to the other side? Minus 1. So we're going to have y minus 1 equals x squared. How do I undo the squared? Square root. And technically, aren't we on the positive side of that where the region is? So I'm just going to keep it as square root of y minus 1, positive square root of y minus 1. So this is square root of y minus 1. Okay. We're going to take this in little tiny bits. Okay. Remember the thing yesterday where we had, if we look here, it's the purple brown line and the green line, and here it's the purple and the blue. So how many integrals am I going to have just for that piece? 2. Okay, good. So I know I'm going to have to do 2 volumes of revolution. I'm starting with pi for volume of revolution, right? So I've got pi something plus pi something for those 2 volumes that I've got to deal with. Okay? On this first one, let's deal with the bounds, and then we'll deal with the actual revolutions here, okay? So what is this for? I'm looking at the y values. What's this first bound here? 0, good. Where's the where do they cut in half? 1. Okay, so this one's going to start at 1. Where's it going to end? What does it look like on the graph? 2. Okay, so we've got the bounds dealt with, okay? Now on each one of these, I have and I did not leave room for my dx. I have an outer and an inner. And I have an outer and an inner. Okay. Sorry, I made this the second problem. I should have saved it for the last problem. Okay. So I'm going to start with this guy down here. Okay. So I'm starting right there. Which one is the outer function? The green or the purpley brown? Yeah. Green or purpley brown? Which one's outside? Which one's further away from the axis of revolution? I should say that. The purpley brown, the ugly purpley brown one, right? Okay, so that's...
Interesting color, purpley brown.
It's brown there, and then I had to go over it in purple because I don't have brown. So, yeah. It's purpley brown today. All right. So what is the value of that function right there? What line is it? Go back here and look. 1, because that one's my outer is 1. Okay? All right. And then I got to go all the way from there all the way to the sparkly line. So I'm subtracting. What's the value on the sparkly line? -1. And we're going to stop on that. That's it on that piece. Okay? Not even going to worry about turning my double negatives to positives, okay? All right, now we're going to go to the inner function, which was the green you told me, okay? So we're doing right minus left. So my right, what's the value of the green? 0, good. Minus the axis of revolution. What was my axis of revolution again? -1, good. You're welcome. All right, so that was the bottom region right here, right? This graph's a mess now, isn't it? Okay, let's now look at the top region. So now I'm looking at this. Could I add another column? I'm looking at where the purple highlight is, right? It's too thick for me to draw an arrow. All right, so I've got purpley brown and I've got blue. Which one is further away from the axis of revolution? Purpley brown. Okay, so I'm doing purpley brown. I've still got to do this thing all the way from here to here. So purpley brown, what's the value of the purpley brown? 1. I'm going to subtract my sparkly axis of revolution. What's my value on my sparkly axis of revolution? -1. Okay. All right. Now you told me that the inner one or the one closer has got to be the blue, right? So I've got to do blue. What's the what's my blue function? Yep, square root of y minus 1 minus the axis of revolution, which is -1. That's a huge mess. I'm so sorry that was the second one. That's going to make the next couple look easy, which is good because we're going to shift the axis of revolution a lot. Okay. Any questions? That one was intense.
I'm not good at solving that.
We're not going to solve it today. Aren't you glad? Actually, it's mostly numbers, isn't it? It's not variables. The trig kids I'm driving them crazy right now because we're doing like the trig identities where there's absolutely no numbers except for like the 1 in the Pythagorean identity. They're like, where did the numbers go, Mrs. Ballard? All right. If only they knew, we'd rather not have numbers, right? Okay, let's read through the second one. So find the volume of the solid form by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 1, x equals 0, x equals 1. About the line y equals -2, shade the region being revolved, draw the axis of revolution, draw a representative rectangle. So it's the same equations, right? I'm not going to re-highlight them all. That's my region. My axis of revolution is at y equals -2, which is down here. Okay, so that's what I'm revolving around. The good news is I'm in the x direction. I don't have to change my equations and do any of that crazy stuff. Okay. All right. What is my region that I'm revolving touching my axis of revolution? No. So disk or washer? Washer. So that means we need 2 circles, right? We need an outer circle and an inner circle. Yes, Ellie?
How do you know that that's the shaded region?
Because it told us all of these, oh, not that color. It told us all of the boundaries right here of the region. Okay, does that make sense? So those should all be on the outside, and where they all intersect, that becomes the region. Okay? Because it looks like, now that I drew this axis here, it looks like there's another region down here, right? But that's only because we created the axis. Okay? All right. Let's take a look at doing the setting it up. Okay? So volume of revolution, what do we start with? Pi. Good. Okay. We need some bounds, and we're going in the x direction. So what are my bounds? 0 to 1. Perfect. Okay. I know I'm doing a washer because my region is not touching my axis of revolution. Okay, so I'm setting that up. I'm going to have my outer, I'm totally abbreviating now, and my inner, right? And if you need to write those up there right now, that's fine, okay? They're not going to fault you for that on an AP test, all right? Okay, which function? Now I'm looking at the blue function and the red function, right? Because those are going to be my outer and my inners, okay? Because they're going in kind of in the vertical direction there. Which one is further away from my axis of revolution? The blue or the red? Blue. Okay, so I want my outer to be blue, I want my inner to be red. So now I've got to do top minus bottom in there. So my blue to the sparkly line. Which one's on the top, the blue or the sparkly line? And I know it seems like a silly question. It's going to be really important once you see the next one, okay? All right, so the blue. So blue is top. So I'm using x squared plus 1 on the top. What operation am I supposed to put in there next? Yeah.
Why didn't you solve
Okay, really good question. Because on the last time I had to solve it, right? Because I was in, my axis of revolution was vertical. Okay, is my axis of revolution, oh boy, this time is horizontal. So I did not have to do the solving like I did the last time. Does that make sense? Okay. All right. So I have to do subtraction. What is the value that's on my axis of revolution now? -2. So -2. Okay. So I've got blue taken care of. Outer is done. Now I've got to do inner, which was my red. Okay. So I'm doing the red to the sparkly line. Which one is on the top? Red. What's the value of the red? 0. Good. Minus is the operation. And what's the value on the sparkly line? -2. That wasn't so bad. Okay. Are you ready to see the College Board's favorite problem? Because this isn't it. The next one is. Okay. All right. Any questions on that one? All right. Let's set this last one up. We're going to get through this one before we leave today. Okay. All right. So I'm going to read it with you. This 100%, I would put like 1,000,000 stars by this one. This is the one the College Board loves to give you because it's seemingly like the hardest one. Okay? I don't think it's that bad if we set it up the way we've been setting it up. Okay? So find the volume of the solid formed by revolving the region bounded by the graphs, and I don't know why it typed it like this. Y equals x squared plus 1. I'm just going to put my 1 there. Y equals 0, x equals 0, x equals 1. About the line, x equals 2. Shade the region being revolved. Draw the axis of revolution, and draw the representative rectangles. Did my region change at all? No, same region. Okay. All right. I do need to draw the line, the axis of revolution, which is the line x equals 2. So it is up here. So this is a shifted axis above the region.
Is it x equals 2 or y equals 2?
It should be, oh shoot, I want it to be y equals 2. We're going to change this. Thank you for catching that, Ellie. That's a typo. It should be y equals 2. Okay? Good eyes. Good eyes. Okay. So we're going to change that to y equals 2. So I want they love this problem. I don't know what it is, but they love it. Okay? All right. So is my axis of revolution touching my region in more than one place? No. So do I want a disk or a washer? Washer. That's the answer today is washer, right? Okay. So volume of revolution starts with what every single time? Pi. Good. Okay. I'm still looking at what bounds? 0 to 1. So we didn't change that. We're just changing the inside here. So I know I've got to do a washer. I've got to do something squared minus something squared dx. Okay. I've been very careful in the way I've been asking you the questions today. Okay. So I'm going to try to identify my outer and my inner. Okay. I'm looking at my axis of revolution. Which function is further away, the blue or the red? Red this time. So red just became outer. Okay. Now look at what I have there. I still have to go top minus bottom. So I'm looking at the sparkly line and the red. Which one is on the top? The sparkly line. So that's my axis of revolution. What's its value? 2. So I'm going to go 2 minus... Okay. The red line. What's the value of the red line? 0. Perfect. Okay. Let's go now to the blue one, right? The blue one became my inner. I got to go top. Oh, I'm doing the wrong thing there. Sorry, I'm going to accidentally. Okay, blue. All right, so I've got to do top minus bottom on my blue. Okay. So I'm going between the axis of revolution and the blue. So which one is on the top, the sparkly line or the blue?
Well,
Right here, this little chunk right here. Which one is on the top of this?
that was the most satisfied.
The sparkly line. What's the value of the sparkly line? 2. Got to put a minus in there, right? And then what's the value of the blue? This is where I should really have a parentheses there because I have a function that's back there and I don't want to mess up the sign. Okay? If you go very methodical like we've been doing, okay, it shouldn't be a problem. But they love having that shifted axis above. Okay? All right, you guys did good today. Make sure you practice tonight, okay, because we're going to come in and we're going to try to get through a couple free response problems. Come to class tomorrow because I'm going to put some stuff out there that's going to help your grade that you can work on over the break, okay? Because remember, there's a bunch of stuff Mrs. Ballard hasn't graded yet, so we're going to try to make up for that without having to maybe retest is my hope, okay? So please, please, please make sure you're in class tomorrow. If not, I'll post the instructions on stuff. So make sure you read through it and you plan to do some calculus over the break. We do not get to take the week off this time. Okay? All right. Have a great day, you guys.